we talked earlier in this episode about how inference is most of what's happening at scales with AI models. Training is an important part, but inference is most of what we're doing with GPUs these days. And so you talk in the book about multi-node inference and disaggregated architectures. What the heck are those?
Yeah, welcome to another chapter that was supposed to be a single chapter, or topic that was supposed to be a single chapter.
And so this is one of the three books, one of the three sub-books.
Exactly. Inference, there's a lot going on in inference that folks probably on the surface don't realize. So stated like simply, with inference, we're doing just a forward pass where we've got the weights, which are the parameters in this, let's say it's a trillion parameter model. We just need to compute the answer. Boom, just go forward. So on paper, this seems extremely simple. In reality, transformer-based inference, there's a lot of places for things to slow down. And so there's a lot of caching that needs to happen so that we're not recomputing things on every, So think of when you go to ChatGPT or to Claude, you type in a query. It's like it is going to look at all of the context that you've passed in. It's going to compare everything to like everything else that's in there. It's going to find things that are relevant. And it would have to do that the same way every single time on every single query, for example. And yes, even within the exact same query, it's doing that many times because it's generating the next token and the next token. And so there's something called a KV cache. Funny enough, I was going to put KV cache on my license plate because I just shipped my car from another place, and somebody in California has already taken the word KV cache on their license plate. So I'm like, that's how popular KV cache is.
You can probably in any other state in the US still get that.
Totally, right? So someone beat me to it. But think of it just like any sort of cache system where you're like pre-computing. But these on a single query, these caches can be humongous. I mean, especially with people that are uploading documents that are trying to scan things. There's a lot of computations happening. So now you've got a case. So there's building the cache, which is step one, and then there's actually generating the next token, which is step two. And so, getting like starting to actually generate the response. So those are called prefill is the first step, where it's like generating all of these computations. That's extremely, extremely compute heavy. And so that's where you potentially want a node or a set of nodes in your cluster that are configured differently. So memory bandwidth, it's still important, but it's not as big of a deal as the second step, which is actually generating those tokens, because that second step has to move all the weights back and forth, from your like GPU RAM, sometimes CPU RAM, like based on how big the GPU RAM is, sometimes on disk, right? So these are very different configurations, and so you will often hear people talk about disaggregated PD, which is disaggregated prefill decode. I would guarantee you, if you are going for like an interview in 2026 and need to study something for your interview, it is going to be about this prefill decode. It's going to be about KV cache. So if you're going to talk to any of these big labs in any sort of engineering capacity, study. I can't remember what chapter it is in my book, because it was supposed to be a half a chapter actually, and it ended up being, I think, 3 or 4. So there's trying to understand it, and then there's trying to optimize it. Yeah.